Hi everyone! Today's topic is square completion. You can do it correctly and quickly. Also for factorization, it is useful. Okay, let's get started. 9 is 7 plus 2. 5 is 7 minus 2. With this Hinge product formula, it's 7 squared minus 2 squared. This operation is called square completion. From now, let's use this formula, the M and H formula. M is a mean of A and B, and H is the mean of A and negative B. Call this the Hinge mean, like 9 plus 5 over 2, squared minus, and the Hinge mean, 9 plus neg 5 over 2, squared. Once again, the mean, 16 over 2, squared minus, and the Hinge mean, 10 plus neg 6 over 2, squared. Once again, the mean with squared minus. When taking the Hinge mean, place negative to the smaller, which makes the Hinge positive. Even placing negative here, we get the same result. Neg 1 squared is 1 squared. Once again, when the product has a common part, leave it and take the rest for the mean and the Hinge mean. Move on to practical examples. It's important. The common x. Then take the ones places for the mean and the Hinge mean, 3. Once again, the common x. Then take the ones places for the mean and the Hinge mean. Imagine this. Once again, common x, the mean, and the Hinge mean. Imagining this. Once again, common x, the mean, neg 8, and the Hinge. Imagining this, 8 over 2. From the intercepts, you can get the vertex. Move on to factorization. We can factor it as the Hinge product. When you factor it, don't expand it. Like this. It takes time. Instead, take the negative 9 as 3 times neg 3. Then common x. 5 plus 3 and 5 minus 3. Once again, 4 times neg 4, then common x, neg 8 plus 4, and neg 8 minus 4. Once again, 10 times neg 10. Neg 1 hinge 10. Once again, hinge root 3. Common x minus 1 this time. Then hinge root 3. From the vertex, you can get the intercepts. Once again, imagining hinge root 5, common x plus 6, hinge root 5. You can omit writing this. Once again, here is positive, not negative. We cannot use the hinge product. The graph has no x-intercepts. But taking positive 1 as minus negative 1, it's hinge root negative 1, hinge I. So x plus 3, hinge I. From now, when positive, there is I with hinge root 2. So x minus 5 and the hinge. Next example, from a high school admission test here in Japan. Multiplying here takes too much time. Instead, square completion, like common 200, the mean, and the hinge mean. 3 makes negative 9, which cancels out positive 9. Next example. Let's make 160 and 156. Why? The same thing happens. The hinge mean makes negative 4, which cancels out positive 4. Move on to a general formula. M&M formula. The hinge is the mean. I'll show you what it is. Common factor x. It's x plus 0. Then the common x. The mean is 4. 8 over 2. And the hinge mean, also 4. From now, let's do this way. Common x, 6 over 2. M&M, 3 squared. Once again, common x, neg 12 over 2. And M&M, 6 squared. Actually, the mean is neg 6. But neg 6 squared is positive 6 squared. Still 36. Once again, common x, neg 2 over 2, and M&M, 1 squared. Practical examples. we initially ignore the ones place, like this. Common x, 8 over 2. 4 squared with negative, but this time here. And the sum. Once again, 6 over 2, m&m here, and the sum. Once again, neg 14 over 2, and m&m here, and the sum. Once again, neg 3 over 2, and m&m, and the sum. Practical example for factorization. If you find it hard to factor the ones place, just try square completion. Once again, from a high school admission test here in Japan. Next example. We can use Skelting also for square completion, as in video 19. After a hinge product, distribute 2 to the constants. Next example. When the x place is an odd number, make it even, giving expo 2, hiding expo half, then square completion. This might be square number. 3200 requires 50. Then this 9, 3 or 7, as in video 5. This time it was 7. After the hinge product, distribute half to the constants. Next example. Factorization problem from a high school admission test here in Japan. Multiply this part first. We can make the common part the mean of the rest, and the hinge mean. This is 2 to the 10. 32 squared. Then factorization. It's done. The history of square completion. Long ago, it was hard to solve this equation, so they substituted many numbers. 7 times 2, 7 times 7, as in video 1. a bit small. How about 0.75? They continued this process until satisfied. But around 1000 years ago, square completion was found. They already know square root of 3. So x plus 1 is around 1.73. We can solve it without substitution. Square completion made 2 unknowns only 1. Let me call this kind of operation singularization. You'll learn many ways of singularization for solving equations, max and minimum problems, and so on. Okay, let's move on to the drill. This video continues in video 22, square completion and quadratic formula. Okay, thank you for watching. See you next time. Bye.